Good morning, dear student. Today we are going to discuss topic analog to digital converter. So let us see what is analog to digital conversion. Analog signal is a continuous function of time, and digital signals is a discrete function of time with a specific level. So from the figure, both the signal are clearly shown. So let us see what are the advantages of digital over analog signal processing. For digital signals is flexible in configuration. It has high accuracy. Storage facility in magnetic media is also high. It has minimized cost, and transportability of digital signals is also easy. So analog to digital converters mainly translate analog signals, that is real world signals like temperature, pressure, voltage, current, distance or light intensity, into a digital representation of that signal. The digital representation can then be processed, manipulated, computed, transmitted or stored. ADC work to convert analog, that is continuous infinitely variable signals, to discrete, that is digital signals. In more practical terms, an ADC convert an analog input such as a microphone collected sound into a digital signal, that is a series of binary 1 and 0. It is a block diagram of basic analog to digital conversion and digital to analog conversion method implemented in a communication system. In many cases, the analog to digital conversion process is just one step within a larger measurement and control loop where digitized data is processed and then reconverted back to analog signals to derive external transducers. These transducers can include things like motors, heaters, and acoustic drivers like loudspeakers. The performance required of the ADC will reflect the performance goals of the measurement and control loop. ADC performance needs will also reflect the capabilities and requirement of the other signal processing elements in the loop. Basic operation of ADC. An ADC samples an analog waveform at uniform time intervals and assigns a digital value to each sample. The digital value appears on the converter's output in a binary coded format. The value is obtained by dividing the sampled analog input voltage by the reference voltage and then multiplying by the number of digital codes. The resolution of converter is set by the number of binary bits in the output code. The digital output code is equal to the analog input divided by the reference input. An ADC carries out two processes, sampling and quantization. The ADC represents an analog signal which has infinite resolution as a digital code that has finite resolution. The ADC produces 2n digital values where n represents the number of binary output bits. The analog input signal will fall between the quantization levels because the converter has finite resolution, resulting in an inherent uncertainty or quantization error. The ideal sampling, natural sampling and flat top sampling is shown in the figure. The sampling process represents a continuous time domain signal with values measured at discrete and uniform time intervals. This process determines the maximum bandwidth of the sampled signal in accordance with the Nyquist theory. So it is shown in the figure that changing analog signal to digital signal includes sampling, then quantization and coding process. Nyquist criteria requires that the sampling frequency be at least twice the highest frequency contained in the signal, or information about the signal will be lost. If the sampling frequency is less than twice the maximum analog signal frequency, a phenomenon known as aliasing will occur. Aliasing is a condition in which frequency signals outside the desired signal band will, through the sampling process, appear within the bandwidth of the interest. And ADC performs this conversion by some form of quantization. mapping the continuous set of values to a smaller set of values, often by rounding. As a result, the analog to digital process will always involve a certain amount of noise or error, however small. Different type of converters achieve this quantization in different ways, depending on their architecture. Each ADC architecture has its own distinct strength and weaknesses. The quantization process is shown in the figure, where quantized value is shown, which is taken from the analog signal. Analog signal is shown by the green color, and we can see the digital output, which is shown by the brown color. Main type of ADC converters. So there are different types of analog to digital converters, like counter type, ramp type. Another is the successive approximation, dual slope type ADC converter, integration type analog to digital converter, parallel conversion that or flash type A to D converter, and parallel series conversion. So ADC performance factors. There are many performance factors of the analog to digital converter. That is an ADC signal to noise ratio, ADC bandwidth. The signal to noise ratio reflects the average number of non-noise bits in any particular sample. In ADC bandwidth, we can determine bandwidth by evaluating the sample rate, the number of times per second the analog source is sampled to generate discrete values. The RAM type ADC is shown in the figure. The counter type ADC is the basic type of ADC, which is also called as the digital RAM type ADC or staircase approximation ADC. In counter type ADC, it consists of the comparator, counter, control unit, latch, D2A converter. From the comparator, the input voltage and the reference voltage, which is generated by the DAC, are compared. If it is high, it can activate the clock of the counter. If counter receives the call, it increases the count pulses. If it is then it is given to the DAC. DAC again convert the equivalent analog signal of digital to analog and equivalent analog output, which is again compared to input signal. So this process takes place until the comparison of input signal and the reference signal becomes zero. When the comparison of comparator is zero, the clock will not be received by the counter, and that output of the counter is given to the latch, and we will get the equivalent output, which is equal to the analog input signal Vin. Advantage of the counter type ADC. It is simple to understand and operate. Cost is less because of less complexity in design. Counter type ADC disadvantages. Speed is less since each time the counter has to begin from the zero. There may be conflict if the next input is sampled before completion of one process. The maximum conversion time in A to D in counter type ADC is equal to the 2 to the power n minus 1 T clock, where T clock is the duration of clock pulse and n is the number of bits of ADC. Here we can see the conversion time of 1000 data. So we can see the conversion time of 10 is greater than the conversion time of 8. Now another A to D converter is successive approximation A to D converter. A sample and hold circuit to acquire the input voltage Vin. In electronics, a sample and hold circuit is an analog device that samples the voltage of a continuously varying analog signal and holds its value at a constant level for a specified minimum period of time. An analog voltage comparator that compares Vin to the output of the internal DAC and output the result of the comparison of the successive approximation register. A successive approximation register sub-circuit designed to supply an approximate digital code of Vin to the internal DAC. An internal reference DAC that for comparison with V reference supplies the comparator with an analog voltage equal to the digital code output of the SAR. Successive approximation method is shown in figure. Next is integrating type or dual slope type ADC. The dual slope ADC mainly consists of 5 blocks: integrator, comparator, clock signal generator, control logic, and counter. The input voltage is applied to an integrator. The output of integrator is connected to one of the two inputs of the comparator, and the other input of a comparator is connected to the ground. The conversion time is equal to T1 plus 2n minus 1 into T. So total conversion time T is equal to 2n minus 1 into T. It consists of comparator, timer and control unit, oscillator, and counter. Advantage: the linearity is very good and extremely high resolution measurement can be obtained. Its main disadvantage is the slow conversion rate, often in the range of 10 samples per second. In applications where this is not a problem, such as in measuring temperature transducers, a dual slope ADC is a good choice. Now, another A to D converter is a flash type A to D converter. It is also called as parallel A to D converter. This circuit is the simplest to understand. It is formed of a series of comparator, each one comparing the input signal to a unique reference voltage. The comparator outputs connect to the inputs of a priority encoder circuit, which then produces a binary output. A flash ADC, also known as the direct conversion ADC, is a type of analog to digital converter that uses a linear voltage ladder with a comparator at each rung of the ladder to compare the input voltage to successive reference voltage. Total number of resistors here are 2n. N is the number of bit. Total number of operational amplifier is equal to 2n minus 1. Means if it is 3-bit flash ADC, then 2 to the power 3 equal to 8 resistors are required, and 2 to the power 3 minus 1, that is 7 comparators are required. And if it is a 8-bit flash ADC, then 2 to the power 8 equal to 256 resistors are required, and 2 to the power 8 minus 1, that is 255 comparators are required. So it is shown in the figure. We have 7 comparators, and we have one 8 line to 3 line priority encoder. So voltage divider network is connected at the input of the comparator network, and it is connected to the V reference and the ground. The output of comparator is given to the decoder circuit, which finally convert the analog signal into digital signal. Advantage of flash type A to D converter is it has very high speed, fastest due to parallel conversion. Disadvantage of flash type ADC is it is large and complex and costlier. It also has high power consumption. Flash type ADC is useful in large bandwidth application. Examples: satellite communication, radar processing, and oscilloscope. So this is all about the type of analog to digital converter. Thank you.